Today we're going to go on to 5.3 notes. We are dealing with exponential functions still. This time we're going to learn about 3 different formulas and how we can use them in word problems and real life scenarios. The first one that we have is exponential growth, and that is when something is increasing exponentially over time. Generally we're dealing with money with these. So here we have our formula, f of x equals a and then times in parentheses 1 plus r to the x. Now each of these variables means something different. So we're going to start with a, and our a is our initial amount. That's like the amount of money that we're starting with. And then we have r. R is the growth factor. They're going to give it to us as a percent, but it's important to remember that it has to be as a decimal when we use this formula. So I'm going to go over how to change a percent into a decimal really quick if you do not remember that. So you just want to move the decimal point 2 places to the left. And that is for changing a percent into a decimal. And then finally we have x, and that is our time, and that is in years. And so we're going to use this in practice with number 1. So the original value of an investment is 1,400, and it increases by 9% each year. So we need to use an exponential growth function to find the value of the investment after 25 years. So what I like to do with these problems is to circle or box in important information that's going to help me solve it. The first thing that's important to note is that this says increases. Whenever you see increases, that's how you know that we're going to be using exponential growth. The next thing that's important is all of the numbers. So we have our original value, we have how much it's increasing by, and then we have the number of years. So I'm going to write out our base function here that we're going to use. We need to fill in these variables. So first we just want to write a function, and then we're going to use that function to solve for x as 25. So we would get y equals our initial amount, I circled, was 1,400. And then we have in parentheses 1 plus, then we have r. So r is the growth factor as a decimal. So it says 9%, and 9% as a decimal, if you move it over 2 places, is 0.09. And then we have to the x. So x is our time in years. So this would be the formula that we would write out, and now they want us to find after 25 years. So now we're going to replace that x with 25. And now we solve it. So I would just enter this in your calculator, just as you see it here. If you need some help with that, I can help you in class. And you should get 12,072 and 31 cents. Okay, let's try another one. So again, we see the word increasing, and that tells us we're going to use the growth formula. We have our initial amount, the percent, and the number of years. So we're going to do the same thing. We're going to use that same formula. So A, our initial amount. Then we have 1 plus r, so 4.5 as a decimal is 0.045. And we would have to the x, and they want us to find after 7 years, so we're going to replace that x with 7. And again, just enter this all into your calculator, and you should get $204,127.91. Okay, let's go on to our next formula here. Now we have exponential decay, and so that is when it is exponentially decreasing over time. And the only difference in our formula here is that now we are subtracting right here. So now it's minus instead of adding. We have our same variables here. We have our a, which is our initial amount. We have r, which is again a decimal, and we have x, which is our time in years. So very similar to the other one, and this time we're looking for words that mean decreasing. So here we have depreciates, and the next one we have decreasing, and those are the words that are going to let you know that you're going to use the decay function instead of the growth function. So number 3 says a farmer buys a tractor for $50,000. If the tractor depreciates 10% per year, use an exponential function to find the value of the tractor in 7 years. So we have our initial amount, the percent, and the years. So y equals our initial amount times 1 minus, and we have r, 10% as a decimal, is 0.1. So we're going to do 1 minus 0.1, and that is to the x. And they want us to find when x is 7, so I'm going to replace that x with 7. Again, you can just enter this in your calculator. In our parentheses here, we would have 0.9. You can write that, or you can do 1 minus 0.1. Either way should get you the same answer. So y equals $204,127.91. We have another one that says the population of Campbell County, Kentucky has been decreasing. So again, that tells us to use the decay formula at an average rate of about 0.3% per year. In 2000, its population was 88,647. I'm going to circle that whole thing. And they want us to write an equation to represent the population since 2000. If the trend continues, predict the population in 2010. So here they want us to write an equation and then predict the population in 2010. So let's start with our formula here. Y equals our starting amount is that population in 2000, so 88,647, and then we have 1 minus, and we have 0.3%. Be careful here because this is 0.3%, so when you move it 2 places to the left, you're going to get 0.003. And then to the x. So they don't explicitly give us the number of years here. They tell us the years, but not the amount of years. So we start in 2000 and we end in 2010. And so when we subtract those numbers, there's a 10-year difference. And so that is what our x is going to be, is 10. So now we put this in our calculator and we solve it. And you should get 86,023. And you're going to get point something, but you always want to round down on these ones because you can't have a fraction of a person. And so you have to round down. We have one more formula here and then a problem of 3 parts to try. So this one is compound interest. So compound interest is the interest that is paid on both the principal and the interest that has already been paid. So compound interest formula is again exponential growth function. So we have growth, so we are adding here. We have some new variables. So we have our A is the amount paid, P is the principal amount, and that just means the starting amount, what we start with. We have R, our rate of interest, again as a decimal. N is the number of times per year the interest is compounded, and T equals time. So I'm going to go over n really quick, the number of times per year. You're going to see a few different words, and so I'm going to write those out and define those for us. So one of them is quarterly. So if it's compounded quarterly, that means that your n is going to be 4. You might see monthly. How many months are in a year? 12. You might see annually, and that just means once per year. Maybe you see daily. Daily would be how many days there are in a year, 365. And you also might see semi-annually, and that means 2 times a year, so it would be 2. And those are some different ones that you might use for n. Some different terms you might see. So let's go on to our first word problem. So Kimberly's family invested in a certificate of deposit for her when she was born, and the interest is compounded quarterly. What is the value of the CD at the end of 5 years? Let's start by creating our function. So A equals, we're trying to figure out the amount. So the principal amount is the starting amount. And so if we look over here, it's our information that we need is over here in this picture, in this certificate picture. The amount deposited right there is $3,000. So that's not the amount paid, but it's the amount that we start with. So that would be our P. Then we have 1 plus, we have a fraction here, R over N. Okay, R is the rate of interest as a decimal. So we have 8%, so we want to change that into a decimal, 0.08. And then that is over N. Remember, I wrote those terms for n, and we are looking at compounded quarterly. And so we're going to put 4 in the bottom. And that is 2, and again, 4 times t, time. And we're looking at 5 years. So now to enter this in our calculator, I'm going to write this out and show you how you would enter this. So you would write, because you don't need that, just 3,000. And now you're going to have to do a multiple sets of parentheses, or your calculator won't calculate it right. So you're going to have to do one set of parentheses first, and then you're going to put the 1 plus. And now when you have a decimal within a fraction, you can't use the fraction symbol, you have to actually divide it. And so we're going to have another set of parentheses here. That's 0.08. And then you have to use the dividing symbol, and then 4. Close the smaller set of parentheses, and then close the whole set. Then you can use your caret, and once again we have to have another set of parentheses because we are doing more than one number in our exponent. So then you'd have the 4 times 5. I can help you with this in class if you need it, but when you put that in your calculator, you should get $4,457.84. So the next one is asking us if it will be greater after 5 years if it is compounded annually rather than quarterly. So now let's do that same formula, but this time we are looking at annually. So the only thing that's going to change is our n. So we have 0.08, and this time it's annually, so divided by 1, and that is 1 times 5. And that would give us 4,407, so it is not. And we have just one more here. So what's the difference if it's compounded monthly rather than quarterly now? So again, same equation, but this time we are doing monthly. So we're going to do 12. Our exponent is 12 times 5, and when you do this, you should get this number, and we want to subtract that from what we got for the quarterly one. And when you do that, you should get $11.70. Please try these 4 for your homework. They will really be beneficial to you.